All right, so for this question, it's asking you to determine what is the relationship between each pair of items. If we look at the first two, you can see that that bottom center of this molecule is the same on that Fisher projection. And so remember when we talked about Fisher projections, we said it's an easy way of spot checking that things are the same or different. But we can see on the top that the top chiral center is different. So we see here that we have an OH pointing towards the left, a hydrogen on the right on the bottom, but on the top one, the chlorine is pointing to the right on one and then the left on the other. So because they're not identical, they don't look exactly the same, because they're not mirror images of each other. These are diastereomers. So A are diastereomers. They're non-superimposable, non-mirror images. So I couldn't just map one on top of the other one. For B, we look at cyclohexane, so dimethyl cyclohexane, and you have these two groups are cis, and then you have on this one, these two groups, one is up, the other, let me draw it the way that they have it on here. So we have these two, and this is 1, 2, 3, and this is 1 and 2. So even though this is cis and even though this is trans, they're actually not even in the same positions. And so these two are actually constitutional isomers. They're not the same structure. So very similar to test number 1, we had to draw constitutional isomers like this. For C, now we have both of them are 1, 2. And so this is cis, so 1, 2 cis. And this one is 1, 2. So this is down and this is up. So this is trans. So they're not the same structure. And we can redraw them so we can see if we had something like this. This one would look something like this. So they're not exactly the same. One chiral center is going to be the same. The other one is going to be different. So one center is the same. The other one is different. So these are diastereomers. For D, we are going to do something very, very similar. So if we were to redraw D, we see that this is up and this is up. So they're 1, 2 cis. And then if I drew this, redrew this like that, you see one is up, one is down. And so again, this is trans. And so the answer to this is exactly like what we saw before. They'd still be kind of like that. And then E, we're going to look at very similar to what we did at the beginning. And so we see that we have chiral centers here, here. So we have them at each of the axes, and we see that these look like they're mirror images of each other, and they look like they could be superimposable on top of each other. But I'm going to give you one little reminder that if you have a structure in which there is a plane of symmetry in the structure, then we would say that this structure would be meso in this case. If we were to look at, so it looks like you have chiral centers, and you do. And when we compare each one of these, however, there's an internal plane. So there's an internal plane right here. And that would make these structures meso. Okay. Another type of meso structure, so if we cut it in half, this side looks like this side looks like this side, no matter what I did. And so this structure would be meso. So there's an internal plane. So think of it this way: if I put a line through this one side looks exactly like the other one. Now, in a lot of cases, meso compounds have an equal number of chiral centers, but in this case, that's not true, that it's an even number, and that's just because there's an internal plane. Now, a reminder about mesostructures is please make sure that you're rotating the structures as well. So don't just like assume what it is, but try to rotate it so that you might see that there could be other ways that the structure could be drawn. So our last one, we see that we have our 3 chiral centers. That bottom one that we have, they're opposite to each other. So the orientation is opposite here. In this middle one, the orientation is opposite, but the top one, the orientation is going to be kind of like pointing in the same direction. But if we were to look at kind of these, you would see that there is a mirror that we could put there, and you'd see that they kind of map each other. So everything is kind of like the mirror images of each other. So these would be enantiomers. So if we were to look at this, there's a plane right here that you could put a mirror, and they look like they're mapped on top of each other. So if I were to try to look at this, these are non-superimposable mirror images. The tricky part is because we don't have wedges and dashes, you might not notice that it's not superimposable. So just imagine if I were to take on this side that this OH over here, and I'll try to see, this OH was a wedge. If I were to try to flip it on the other side, it would become a dash. And so I'm going to redraw this so we can see. I'm not going to draw out the whole structure, but we assume that this looks like this as drawn. And if I were to rotate it, you're going to end up with it looking like this. And these would not be the same. Okay, so if I were to try to rotate the second one on top of the other one, the wedges and dashes would actually change. And so there, it's a tricky question because people think, oh, if I just flip it, it would look the same. But no, you have to remember that there are wedges and dashes on there.